Hi, everyone. So in this lesson, we're going to be continuing writing our polynomial equations. But we're going to take it to the next level. More specifically, we're going to learn two additional theorems that are going to help us with certain type of roots that we're going to be told. Before we get into that, though, let's start off with this review question. So it's asking us to sketch this polynomial function here. And I give you the hint that x plus 2 is a factor. Okay, so I obviously don't need that hint because I could just write out the factors of 18. So the 1, 2 is in that list, the 3, and then the 6 and 9, etc. But I don't have to check 1 and -1. I could just go straight to 2, which means the factor is going to be -2. So I could use that to break my polynomial down. Okay, so just to save some time, if not, just check the roots with the possible rational roots with the synthetic division. Okay, so if I look at my coefficients here, we have a -1 leading coefficient, a 4 in front of the quadratic term, 3 in front of the linear, and a -18 as the constant. Okay, so I'll bring down the -1. -2 times -1 is a +2. That'll give me a 6 if I add them. 6 times -2 is -12. That'll give me a -9 if I add them. -2 times -9 is a +18, which does in fact give me a remainder of 0, which it needs to because the factor theorem tells me that if it is indeed a factor, the remainder needs to be 0. Okay, so from this, so we know x plus 2 is a factor, so we were told that one. Okay, so after I break it down and ask myself, what do I need to multiply by to get the original? We get this here, so it's a -x² plus a 6x plus a 9. Okay, so if I want to sketch a graph, we need to find the roots of the zeros. So we already have the -2. So that one came for free, more or less. Okay, so here we sort of have a trinomial, but this negative's in the way. So what I could do is I could just factor the negative out, right? So remember, the a could be anything. I can make a 100 here. The root is still -2, right? So no matter what a I put in front here, the roots aren't going to change. So if I take a negative out, that should make it easier to factor. So if I put a negative in front, that'll become +x², a -6x, and a -9. Sorry, this is -9 here, so that'll become a +9. So it should be negative, this is a +9. Okay, so it looks like we can't factor this because -3 and -3 will give me a -6 in the middle there, and -3 times -3 is a +9. So it looks like we have a double root here, x equals +3. So I could say it's either a double root or it has a multiplicity of 2, right? Because remember, multiplicity is just how many times a factor repeats. So this repeats 2 times, so we know how that'll behave on the graph. So let's go ahead and sketch my graph here. Okay, so now that I know my roots, I can put that on my, let's x and y first. So -2 is one of my roots, and then +3, a little bit more over 1, 2, 3. Okay, so those are my two roots. If I go back to my original, my leading coefficient is negative, which means it's going to be decreasing on the right. Okay, it's an odd degree, it's cubic, right? So that's opposite direction. So if that side is going down, this side would have to be going up. Okay, just by looking at the equation, I know my y-intercept, it's going to be a -18. So if you plug in 0 for all the x's here, those all become 0. So -18. So I need to go down to -18, just a sketch. So I'm not going to be too concerned with my scaling here. Okay, so -2 only happens one time, so that's a single factor, so it's just going to pass through that like a normal line. We'll go down to the -18 turn around here. And just by the graph, you could kind of tell it needs to bounce in order to get here. You can't pass through because then we'll end up there. And just, we do have a multiplicity of 2, which means it is going to bounce. It's going to bounce off the here and then go downward. So that'll be an accurate sketch. Remember that. So that would be a more or less accurate sketch of my graph. The -18 might be a little down more depending on my scaling, but the other features is mainly what I'm looking for, the roots, the end behavior, and how it acts at each of the roots. So in that case, just the bounce. All right, let's continue here. So in order to solve problems with imaginary, we're going to first learn two new theorems. Okay, so these are two separate theorems. We're just going to combine them, so it's just easier to look back at. And they go hand in hand, so just to have them in the same spot will be helpful. Okay, so this is the irrational conjugates theorem, and the complex conjugates theorem. Okay, so those are the two theorems. They basically say more or less the same thing. Okay, so starting with the irrational tells me if a plus radical b is a zero of my function. So you remember, if I have a zero that looks like this, or something like, I don't know, like 2 plus radical 3 or something, that would either come from completing the square quadratic formula. So in either of those forms, whenever we do take a square root here, we need to remember the plus or minus, right? So I'll never just have a plus if I'll never have just 2 plus radical 3, I'll also have 2 minus radical 3. So because that plus or minus, this theorem tells me that if I have a plus radical b as a root or a zero, then a minus radical b would also have to be a zero of f. Okay, so in a problem, if basically this tells me, if it tells me, I don't know, 5 plus radical 7 is one of the roots, I don't need to be told it. I just automatically know 5 minus radical 7 is the other root. So these sort of happen in conjugate pairs. Okay, the same is going to be true with imaginary numbers or complex numbers. So my complex conjugates theorem tells me if a plus bi, so that's my standard form for complex, right? The real plus the imaginary part. And the same exact wording here. So if that's a zero of f, then a minus bi would also have to be a zero of f. Okay, so you're never going to be, I'm not going to say never, but in most cases, you're never going to be told both. It'll just tell you one of them, and you just have to know that the conjugate has to be there as well. Okay, so if you have like 2 plus 5i is one of the roots, okay, then 2 minus 5i is your second root. So that automatically comes for free. Okay, and the same would be work if you just had like regular, if I just had like 3i, right? Because that's the same as 0 plus 3i, the a plus bi. So automatically 0 minus 3i would be a root. So if you get rid of the zeros, so basically if 3i is a root, automatically you know negative 3i is a root as well. So these will always come in conjugate pairs. Okay, so using these theorems, let's see if we can write some more. Start off basic, and then we'll work up to the ones that I think are the most difficult. Okay, so write equation of polynomial least degree with roots 2 and 4i. Okay, so according to my complex conjugate theorem, so if 4i is a root, that means automatically you know negative 4i has to be a root as well. Okay, so it looks like we have 1, 2, 3 roots. So the least degree possible would have to be a third degree, right? Because some of this could have like a multiplicity of 2. I could just have a double root there, triple root, like happened 7 times. So it could be as many higher degree I want. So when it says least degree, it means the bare minimum. So we have 3 roots, so the least degree would be cubic. So degree 3. Okay, so remember to write out my formula, it's x minus root 1, x minus the second root, and x minus the third root here. Okay, so that's my factored form. So if I go ahead, it doesn't give me a point it has to pass through, so my a could be anything. So obviously we'll just make it 1 because that's the easiest. You can make it anything, it'll still have these roots. So I'll just leave it as 1 here. So we'll have x minus the first root is a 2. Then we'll have this x minus the second root, which is the 4i, which we're told. And by the complex conjugate theorem, that tells me if 4i is the root, that means negative 4i is the root. So x minus negative 4i, so minus negative becomes plus, would be there. Okay, so we want to write, always want to write this in standard form. So in order to get the standard form, I have to multiply these binomials together. So since these are conjugates, you should always multiply these first, because remember, conjugates have that property where the middle terms are going to cancel, right? So something simple like this, we know when you multiply conjugates, you'll have the plus 2x here, and then you have the minus 2x here. So basically the middle terms cancel. So you only have to worry about the first two, x squared, x times x, and the second two, 2 times 2 is the 4. So you don't have to worry about the middle term. So multiplying conjugates is easier. So if I multiply these ones, I only have to worry about the first terms. So x times x is x squared. And the last term, so negative 4i times a positive 4i. So negative 4 times 4 is negative 16. Okay, and then I times I is I squared. Okay, so when you multiply those, you just, it's basically a difference of squares, right? X squared is x times x, and then 16 is 4 times 4. I squared is I times I. So you go backwards, basically difference of squares there. Okay, so I know I squared is negative 1, right? So negative 16 times negative 1 there is going to give me So negative 16 times negative 1 is a positive 16. Okay, so make the I squared negative 1. Okay, so basically we just have to FOIL this out, and then we should have our final answer. So x times x squared is x cubed. Okay, x times positive 16 is 16x. Okay, then we have the inner term, so negative 2 times x squared is negative 2x squared. We're going to put this in descending order, so let me write the negative 2x squared first, and then I'll bring back that plus 16x, just to have it in order. Okay, and the negative 2 times 16 will give me a negative 32. Okay, so it looks like this would be my final equation. Okay, so it's a lot of multiplying, especially when you have 3 binomials here. But if you have conjugates, that makes it a lot easier. And you'll always have conjugates with complex and irrational roots. So always multiply the conjugates first, and that should be a little easier when you're expanding. Okay, so I want you to, so you should be taking notes, obviously. So once you have that written down, I want you to pause the video, try this one on your own. So try to write the full equation in standard form, and then I'm going to go over the solution now. So after you finish, you could play it and then see if your work matches mine. All right, so at this point, you should have tried it completely on your own. So let's go to the solution. I'll go a little quicker because you should try it and see if your answer matches. Okay, so I have 5. So if I have 0 plus 3i, that means complex conjugate tells me 0 minus 3i would also need to be a root. Okay, so if a plus bi is a root, a minus bi is automatically a root. Okay, so basically get rid of the zeros. So we have, once again, 3 roots, so we should have a cubic. Okay, doesn't tell me a point, so I'll just make my a1. Okay, so we have x minus the 5, x minus the 3i, and then x minus negative 3i is a plus 3i. Okay, so multiply the conjugates first. So first terms, x times x is x squared. Middle term, outer inner cancel, so the last times the last, that'll give me negative 3 times 3 is negative 9. I times I is I squared. Okay, so once I make this negative 1, that becomes negative 9 times negative 1 is plus 9. So that'll become plus 9. Okay, so simply FOIL this out. So x times x squared is x cubed. Negative 5 times x squared is negative 5x squared. X times 9 is 9x. And then negative 5 times 9 is a negative 45. Okay, so my equation that the equation you should have gone would be that. So hopefully you got it right. If not, see where you went wrong. All right, so let's go to the next level. So that was just a single term, just the imaginary term, like 3i. So let's look at ones where we actually have 2 terms, like 2 plus radical 5 or 3 minus 5. So 2 terms there. Okay, so we're writing a function f of least degree. So once again, least degree. Leading coefficient is 1, right? If it doesn't tell you a point or something to stretch it by or whatever, just make it 1 to make it easiest. Okay, so the zeros are 3. So if I have 2 plus radical 5, my irrational conjugate theorem tells me that 2 minus radical 5 would also have to be another root. So it looks like we have, once again, 3. So 3 roots, the least, we have to have a minimum of degree 3. Okay, so it gets a little bit tricky, but we can use our knowledge of conjugates to help this make this a little easier. Okay, so first root, I have x minus the 3 there. So that's pretty straightforward. Okay, so I'm going to do a bracket here because I have to do x minus the entire root. So if my root is 2 plus radical 5, I have to do the entire 2 plus radical 5. Okay, and same thing here. I have to do x minus the 2 minus radical 5. Okay, so when you're doing x minus each root, if you have a binomial two numbers there, you have to do x minus the entire roots there, which means that negative is going to be distributed. Okay, so what I can do here, and I'll explain why I can do this in a moment, but whenever you're dealing with, these are basically conjugates, you just have the opposite sign here, but they're not quite conjugates because the actual sign here are the same. So what you can do is you can use your associate property and group your terms. So I'm going to move my parentheses. So right now the parentheses are on 2 plus radical 5. So I'm going to move them over to the x minus 2 and then have that plus radical 5 there. Same thing here. I'm going to move my parentheses to the first 2 terms instead. So move your parentheses to the first 2 terms. And then this will be minus radical 5. Okay, so what I did now is now I basically have conjugates. I have that binomial plus radical 5 and that binomial minus radical 5. So these are conjugates, which will be a lot easier to FOIL since I know the outer and the inner terms are going to cancel. Okay, so the reason you could do that, basically, if you did distribute this negative, this first one will become x minus 2. This negative gets distributed there. So that'll be minus radical 5. Same thing here. This will become negative 2 plus radical 5. So basically, if you look at it like this, you'll just have the same two things. So you have the ability to move the parentheses to the first two terms whenever you're doing this procedure. That'll work for complex numbers too, as we'll see. Okay, so now that I have this, so I'm going to multiply these conjugates first before I deal with that x minus 3, since the middle terms are going to cancel. So I'll do the first term times the first term. So that'll basically give me, well, x minus 2 times itself, so x minus 2 squared. Okay, so the outer and inner are going to cancel since they're conjugates, so I don't need to worry about those, right? So whenever you're multiplying with conjugates, outer and inner will always cancel, right? The plus 2x and the minus 2x. So you don't need to worry about the outer inner. So just the last term times the last term. So that'll basically give me a radical 5 times a negative. So a positive times a negative will give me a negative. And then radical 5 times radical 5. Remember, when you that's basically radical 5 squared. And square root into each other. So that'll just become 5. Or if you multiply radical 5 times radical 5, you get square root of 5 times 5 is 25, which is also 5. Okay, so multiplying those radicals, since the radical goes away, is a little easier there. Okay, so after you multiply the conjugates together, basically, once again, you'll have a binomial times a binomial, so simply boil this out. But x minus 2 squared, we would want to simplify that first, right? So so if I do x minus 2 squared times itself. So remember, when I'm squaring a binomial, we have our pattern. Just the first term, so the x times the x is x squared. For the inner term, remember, it's a 2ab, so basically smush them together and then double it. So if I have x and negative 2 on my terms, so if I smush them together, I'll get negative 2x and double it, so negative 4x. Okay, and then negative 2 times negative 2 will be a positive 4. And then you still have that minus 5 hanging out there. Okay, so when you FOIL this out, you should get this. You could do it on the side, but you do have, when you're multiplying it by itself, that squaring simpler way of doing it. Okay, so to finish this off, basically, I'll just 4 minus 5 is what? Negative 1. Just become x squared minus 4x and then negative 1. Okay, so it looks like if I multiply these out, we'll have our final answer. Okay, so I recommend doing the box. I'll just go over the box. You could do it horizontally, but the box, I think, is more helpful in organizing the terms. Okay, so x squared times x is x cubed. X times negative 4x is a negative 4x squared. And x times negative 1 is just negative x. Right? The bottom row, basically, this will be negative 3x squared. Negative 3 times negative 4 is a positive 12 for the x term. The negative 1 times negative 3 is a positive 3. Okay, so it looks like if you combine your x squared terms here. So the x cubed, we have nothing to combine that with. Okay, so negative 3x squared and negative 4x squared is negative 7x squared. I'll color code this. 12x minus x is just 11x. And then that 3 here, nothing to combine that with. So it looks like, and it says write a function f, so we'll make sure to call this f rather than just y. So my final function would be here. So x cubed minus 7x squared plus 11x plus 3. Okay. I know it's a lot, especially just looking at it. Be careful with the multiplication. If any errors are going to come up, I feel like it's in this step. Moving the parentheses and foiling it out, it's a lot of work there. So if you feel comfortable, try this second one on your own. See how well you do. We're going to go through it as well here. But we'll definitely do this one more just to make sure we're comfortable. But if you want to try it on your own, pause, go ahead, and then you can check your answer in a moment. All right, so we're going to start going through this. So let's start writing my equation. So we have 2. So 3 plus radical 7 is a root. That means 3 minus radical 7 also has to be a root. So the conjugates will always come in pairs. or the irrational numbers always come in conjugate pairs. Okay, so we do x minus the 2, x minus that root. So to do x minus the entire root, so my root is 3 plus radical 7, so the entire 3 plus radical 7. Okay, and then x minus the entire root of 3 minus radical 7. Okay, so x minus each of the roots. If your roots are 2 terms, x minus, use parentheses around that entire 3 plus radical 7 and 3 minus radical 7. Okay, so using my property, I can move my parentheses. So I'm going to move it around the first term. So the x minus 3 here, keep that plus radical 7. Okay, and here I'm going to move it once again around the x minus 3. So move the parentheses to the first 2 terms, and you'll have the minus radical 7. Okay, so multiply the conjugates first. So we do the first term times the first term. That'll be the x minus 3 times itself, basically. Outer inner cancel for conjugates. So if I do the last terms, we're going to get a negative, positive times a negative. Okay, radical 7 times radical 7 is radical 7 times itself, so squared. So basically just 7. Or square root of 49, which is 7, right? So multiply the 7s on the inside, so 49 will give me 7. Okay, so if you multiply those out, you get that. Okay, so now we can simplify. So x minus 3 squared. So if I FOIL x minus 3 times itself, or use our property, x times x squared, right? Smush them together and double it for the middle term. So negative 3x, smush them together, negative 3x, double it, negative 6x. And then negative 3 times negative 3 will give me a positive 9. Okay, so when you FOIL this out, you should get this here. And now we can combine the 9 minus 7, which would just give me 9 minus 7 is 2. Okay, so when I simplify that second brackets, we should get here. Okay, so we can multiply this out and we'll have our final answer. Okay, so I'm going to do this horizontally just to get practice with both the box and horizontal. I recommend doing the box, especially if you're having trouble or making mistakes with the multiplying. So x needs to go to all 3. Okay, so x times x squared is x cubed. X times negative 6x is negative 6x squared. And x times 2 is just a 2x. Okay, so that x in orange goes to all 3. Okay, and then negative 2 also needs to go to all 3. So negative 2x squared. Negative 2 times negative 6x is plus 12x. Negative 2 times 2 is a negative 4. Okay, so we can combine like terms, so that'll give me negative 8x squared. This will give me what, a 14x? Okay, so my answer, it looks like we have, I think it said function f again. So let me label this correctly. Okay, so we have the x cubed here, nothing to combine that with. Then we have the negative 8x squared as we combined the orange and yellow there, and a 14x after combining that second circle, and then the minus 4 down here with nothing to combine that with. So this should be your final answer. Okay, let's do one last problem here. So looking at one with a complex root, so not just a monomial like 2i, now we have 2 plus i, so binomial there. Okay, so my roots are 3. So if 2 plus I is one of my roots, that means 2 minus I, a plus bi and a minus bi goes common pairs would be another root. Okay, so let's see how we can deal with, instead of a radical, a conjugate. Instead of a radical, we have a complex number here. Okay, so we have x minus the root is 3. Okay, we have x, use brackets here again. Okay, so we have x minus, so the first root we have here is 2 plus I, so the entire 2 plus I. Make sure to put that in parentheses. So x minus the entire root. The x minus the other root would have to be 2 minus I. So make sure you minus off the entire root there. Okay, so same as last time, multiply or FOIL the conjugates first. So these are not conjugates quite yet, but we can move our parentheses around. So I'm going to move my parentheses to the x minus 2. So move it to the first 2 terms plus that I. Move it to the first 2 terms, the x minus 2, and then minus the I. Okay, so now these would be, because stay with the brackets, conjugates. Okay, so the outer and inner are going to cancel, so I just have to worry about the first term. So that times itself is x minus 2 squared. Okay, and I times negative I is a negative, positive times negative is negative, I times I is I squared. Okay, so following that out should give me that. Okay, so same thing when I'm squaring that binomial, I can use my shortcut. Okay, so x minus 2 times x minus 2. Okay, so x times x is x squared. So both the inner and the outer give me negative 2x, negative 2x, negative 2x, smush them together and double it, negative 4x. And negative 2 times negative 2 is a positive 4. Okay, remember I squared is negative 1. So you can have a minus negative 1. So minus negative becomes plus 1. So basically this is going to become x squared minus 4x, 4 plus 1 is 5. Okay, so once you multiply those conjugates out, now you can finish this off by doing this binomial times this trinomial. Okay, so once again, either box method or horizontally. So this x I'll give to all three. So 1, 2, 3. So x times x squared is x cubed. Let me do this over here. I'm going to run out of room. Okay, so x times negative 4x is a negative 4x squared. And x times 5 is a 5x. So orange, that gets distributed to all three. Okay, and then the negative 3 here has to go to all three as well. So negative 3x squared. Negative 3 times negative 4x is a plus 12x. And negative 3 times a 5 here is a negative 15. Okay, so we can combine our like terms. So this gives me negative 7x squared. 5x and 12x gives me 17x. Okay, and then the negative 15, nothing combined with, the x cubed in front there, nothing combined with, and we'll label this f of x as well. So my final equation should be there. Okay, so you see it's the same procedure as the irrational ones with the radicals there. So to make the conjugates, move the parentheses, foiling it with foiling conjugates should be a lot easier than the other one because the outer inner terms cancel. Be careful with the multiplication, and that should be your final answer. Okay, for the last problem here, see if you can do this one on your own. So roots are 2 and 4 plus I. Okay, so write out the factored form, and then you can start multiplying. So I recommend doing the trick or doing the using the property to get the conjugates, so moving the parentheses, and then using the box when you get to your final multiplication there. Okay, so if you want the answer to this one, so x equals 2 and x equals 4 plus I, your answer should be for number 6. If you tried it on your own, x cubed minus 10x squared plus 33x minus 34. Okay, and it doesn't say label it f. You can label f of x, y equals whatever. Make sure it's equation, whether you use f of x, g of x, y, whatever name you call it. That should be your answer. So double check your work and you're multiplying. Make sure you get that as your final answer. All right, that'll be it. So hopefully you took notes on all these problems, tried the ones on your own. Hopefully you can get the work to support this answer. If you still want a little practice, there's another problem. With a slight twist, so you have the same thing there, but it also tells you has to pass through a certain point. So if you input 4, you have an output of 40. So you would also have to find the A term like we did in class. So once you write it out, you can find the A, plug in the point to find the A term. So if you want additional practice, try that one out. But otherwise, that'll be it for this lesson. Feel free to rewind, go back to anything you want to rewatch. Watch it over again if you're confused by anything, but just make sure it's your notebook and hopefully you tried all those ones on your own. All right, I'll see everyone next time. Thank you for watching.